Hey everybody, my name is Ethan Jackson and I'm Senior Director at Microsoft Health and I lead Microsoft Premonition. The goal of Microsoft Premonition is to detect pathogens before they cause outbreaks by monitoring things like mosquitoes, microbes, and viruses in the environment. In particular, it's very important for us to monitor mosquitoes because they transmit so many diseases and they interact with so many things in the ecology. We do this by developing robotic platforms, smart traps, that continuously monitor, lure, and identify things like mosquitoes. This is actually a pretty hard problem because there are over 3,600 known species of mosquitoes alone. And so we need to figure out how to train an artificial intelligence to recognize them quickly. And we need to figure out if we're building devices that will effectively lure them. And so to do that, we built a really unique facility we call the Microsoft Proving Ground, which allows us to bring wild mosquitoes into Microsoft, replicate the environments where they originated from, and then pre-train our AIs and evaluate our robotic designs on the real biology. This also gives us a very rapid prototyping cycle, where if the device isn't working, we can literally 3D print a new version and test it the next day. So let me introduce you to Nicholas from my team, who's going to tell you more about how we designed a proving ground and how it works.
Thanks, Ethan. I'm Nicolas Villar. I work on Microsoft Premonition on the hardware systems and devices side. We needed to build the Premonition Proving Ground in order to have a place that we can carry out our experiments in a safe, repeatable way, in a way that minimizes confounding variables, that controls every aspect of the experimental conditions, so that we can get an opportunity to test our systems and test our devices in a controlled way before putting them out into the wild. In order to carry out our work safely, we built Microsoft's first CDC and USDA certified biocontainment facility. This allows us to bring in wild mosquitoes from all over the world, rear them into adulthood, and be able to experiment with them in our facility in a safe and secure way. So the proving ground is divided into 3 separate spaces. On one side is the airlock that provides a way to safely enter and exit the testing chamber, making sure that all the specimens stay inside and are not able to escape. On the other side, we have the rearing chamber that allows us to rear mosquitoes from eggs through larvae into adulthood, to have specimens that we can carry out our experiments with. And in the middle, we have the experimental chamber. This is where we put the specimens and any devices or prototypes that we might be working on to understand how mosquitoes interact with the technology. It's a space that is very heavily instrumented. We can control many aspects of the environmental conditions and the lighting conditions, as well as any other parameters that we want to vary and test for. So the lighting system has thousands of LEDs built into those lighting panels that are able to recreate very precise lighting, color, and brightness conditions to simulate the day-night cycle in different parts of the world. So we run a simulation where we do calculations about the position of the sun, the angle, the color temperature that would be reaching at a particular place. And in real time, we recreate those conditions. The computer vision system is able to follow individual mosquitoes in flight much more precisely than you could with the human eye. And it's able to track hundreds of these mosquitoes flying at once. And we are able to use that information to plot out their tracks, their trajectories, and see how they might, for example, be attracted to a particular device or a prototype that we're investigating in the space. All of these devices are networked together and connected to the cloud via Azure IoT Hub. What this lets us do is collect all the different parameters, sensor data, everything that we're capturing about an experiment, all the data is being generated during an experiment, and stream it in real time to the cloud many times a second. where it's safely stored and later analyzed. And as it's run, all this data is being captured, collected, streamed to the cloud for later analysis. We're putting a lot of humidity into it. We're controlling temperature, and we're dealing with live specimens. So we like to build a lot of redundancy and safety into the systems that have gone into the proving ground. So I can tell you about the proving ground, and you can see it on the screen right now. But feel free to explore it interactively using the demo that is built into the site.
It's taken a lot of research and development to get us here, and now I'm really excited to make some new announcements. Microsoft Premonition will allow more of our partners to try our technologies. To learn more, just visit our website. Detecting pathogens before they cause outbreaks is a hard problem, and it's very important for us to work with major public health organizations like Harris County Public Health to make sure that our technologies can help. I'm very excited to announce that in the near future, we'll be returning to Harris County, setting up one of the most advanced biological threat detection networks at scale with an initial focus on mosquito-borne diseases. We also know the data sets that Premonition will produce can be used by basic science and also many different research disciplines. So I'm excited to announce a partnership with the National Science Foundation to really think through how these data sets can be used across fields from epidemiology to basic science to therapeutic discovery. For more information about Microsoft Premonition and these announcements, take a look at the sidebar, which has links to blogs, technical deep dives, and more videos. Thank you.